This is the video demonstration of the final project for 6230 Information Infrastructure Protection by Spiky Dog and Dustin Hooven. If you familiarized yourself with the concept of our project, then I'll just briefly introduce you to the components at play and then we'll get to it. So we have 4 virtual machines utilized in this demonstration. The first one here is going to be running both our Beacon Mininet controller and the LDAP client. This here is the Mininet virtual machine itself. Here we have our Microsoft Windows 2008 server running Active Directory. And this is just simulated host outside of the Mininet virtual environment that allows us to issue an authentication request to our Active Directory server because we're not able to do that directly from within Mininet because it is an isolated virtual network and isn't able to communicate with outside systems. So, to show you the state of affairs when we initially start up Mininet, we're adding all of our switches. We were unable to contact our remote controller. We haven't started that quite yet. So we'll come over here, and we have 2 separate projects to actually initiate. One of them is our LDAP server. That's the one that I've launched first. As you can see here, runs on port 2223. And then we have the Beacon Mininet controller itself. And it's also going to start up an RMI server. This one's on 2222. This just allows connectivity in between the different projects that maintain Beacon and our LDAP client. There's a lot of complicated code in there, and it's just not feasible to turn them into a single application. So instead we connected them using RMI. So as we see here, down at the bottom, we've pushed our default deny rules into Mininet. So if we come down here, we'll perform a ping all, which just sends ping requests from each host to every other host. 0% dropped, so all of our virtual hosts are able to communicate with each other over the network. However, because of our default deny rules, when we go to perform any kind of TCP or UDP based communication, that will in fact fail because all of those packets are going to be dropped by our switches. So here we've attempted to initiate a SSH connection between host 1 and host 2. And as you can see, nothing's really happening. And that's just because all of the packets that leave host 1 bound for host 2 are being dropped by the switches because of our default deny rule. This represents a base case in our situation in which an unauthenticated system does not have any access to network resources. This is under the supposition that it's not a server that needs to communicate externally. In that case, you would treat that service as an authenticated user and it would possess its own permissions. But this is an end-user system, so it's a workstation that is only being used by a human at the keyboard. So there's no active services that run on that system that require it to communicate with other assets on the network. So we'll go ahead and stop that for now. And now we need to issue an authentication request that comes from host 1, which if we look at the configuration for host 1, we see that it has address 192.168.56.1. Now because this Mininet virtual host cannot communicate outside of the network with our actual Active Directory server, we have another machine on the outside which has been configured with the exact same IP address, just so that when it performs an authentication attempt, it will respectively appear as though it came from the Mininet host. So we're going to we're not going to authenticate directly. Instead, we're, because this is an Ubuntu system and it's not directly on the network, so instead we have a Perl script that's going to execute an authentication request on our behalf. Now we see over here we had some activity on our Active Directory server, which what happened is when the event came in, we have a trigger that is set up on that event to notify our beacon controller that someone has just authenticated to the network. So as we see here, the account name was Unix_B. They've authenticated to the DustyDog domain, which is our demonstration domain. And we see that the attempt came from 192.168.56.1. So for the purposes of our demonstration, while that machine is actually external to Mininet, the results will be reflected within Mininet as if that authentication request had been issued directly from host 1. So now we'll go back here, and if we look on our beacon domain controller, Mininet controller, we can see a little bit of printout indicating that flow mods have been added. And if we look back at our launcher, we see the output that is reflecting to us the IP addresses, network transport protocols, and ports for which the authenticated user is allowed to issue requests. So now if we come back to our Mininet environment and we try the same request that we did before, we're actually able to communicate now. In this particular situation, the Mininet hosts are not actively running an SSH server, but what this shows is that port 22 is now open between host 1 and host 2. So when we initiated the request, it actually reached host 2, which, because it's not running that service on that port, it refused the connection. Obviously, that's not the most interesting result, so we're also going to have host 3, which is, if we look back at our set of rules, we can see that we can reach 192.168.56.3 on TCP on port 25. Now, normally that's a SMTP server, but the only thing that we really care about for the purposes of the demonstration is that port 25 is open between host 1 and host 3. So to demonstrate this, we're going to run a very simple HTTP server on port 25 of host 3. And now that we've initiated that, we can go to host 1 and actually do a wget for a URL for host 3. And now when we execute that, we see that index.html.3 has been pulled down and saved to the system. So rather than seeing an uninteresting connection refused, which might give you a different impression of whether or not those hosts are able to communicate, we do in fact see that communication is able to take place now. And we note that when we look at our rules, we don't see host 4 anywhere. So the user who's authenticated to H1 doesn't have any rights to access services on H4. So if we tried something like this, then we see that we're trying to connect, but all of those packets again are being dropped by default. So the user H1 isn't going to be able to get to H4 no matter what. So the end result of this is that we're imposing least privilege firewall rules in a dynamic fashion, so that whoever is authenticated on host H1 is only given access to network resources through the firewall as is necessary for them to do their job.